All right, welcome back to Foundations of Programming, Day 10. Yesterday, we finished off our lesson with the inventory manager. We went through a walkthrough. I think Nick was the program that was like the most complete. Today, we're going to try something new. It's still object-oriented programming, and we're still not exactly complete, right? So if I open up, give me a second. I know this is not on the calendar, um, right, but we are ahead of schedule. Streaming guide is supposed to start next week on Monday, or I guess we're supposed to start either today and continue it on Monday, but we were ahead of class, so even more reason to give you guys more object-oriented programming lessons to ensure that you guys really understand the concepts. Um, I believe after Tic-Tac-Toe, if we continue with object-oriented programming and we move forward to streaming guide, and then using files and eliminate them, you guys should be pretty solid when it comes to object-oriented programming. Um, you guys are going to get more practice than most other people have gotten in any FOP class. Uh, for this one specifically, we are not going to break off like we did yesterday and go for an hour and a half. We're going to do small chunks. Um, to make sure that everyone can get from start to finish through the entire program. Right. So first and foremost, let's talk about the tic-tac-toe program. All right. So you're going to create a program that's going to allow two humans to play and compete in a game of tic-tac-toe. Obviously, you don't have a second player, so you're going to be giving both moves for player one and player two, right? From your computer. Your program should follow the following criteria, and as we go through this criteria, we're going to talk about how we can probably do this in classes, right? A game board representation, right? So when we talk about object-oriented programming, design, right? The thought that should be coming to your head is how should I split my responsibilities? What classes should I have? What classes? What should these classes do? And what is the relationship between my classes, right? Um, Before getting like too confused or thinking too much about it, when you think about tic-tac-toe, what are the if you can say three words that come to mind, what can come to mind? That's a question.
Easy.
Okay, easy. Not exactly what I was looking for. If for example, let me start you off. Tic-tac-toe, I can probably picture you require a player, turn based, so you're taking turns, right? So that's a tic-tac-toe concept that first comes to my head. Maybe some kind of display or board, right? When you think of tic-tac-toe, you typically, if you're playing on a piece of paper, you're drawing out your little board, right? The little hashtag where you're going to put your pieces, right? What else comes to mind when you think about tic-tac-toe? You're thinking about X's and O's, right? Each player has their own symbol. And this is kind of how you start brainstorming these ideas. Okay, so I'm probably gonna want to have some kind of player, right? The player, what kind of attributes will this player have?
So the player will have like selection area, and then I would almost think that you'd also have to code in the board, so that way you can the class be
Yeah,
a board.
without straying away from player. Uh, Player, you want to make sure you understand what type of player it is, right? So when you create, so if you make a player object, your player object should either have the X or an O. I can't think of anything else really. Maybe a score, right? An attribute that you might give to this player will be maybe like score, especially if this is an ongoing game where you do something like best two out of three or best three out of five, right? So you might have a score attribute. And as Daniel said, and he hinted towards it, the board, right? Maybe have a board class, a class that whenever you instantiate it, it might have some kind of method that's going to display the board, right? That keeps track of the state of the game, right? So a game board representation. Um, you might actually want to be able to display this board, right? So as we play, how do we know who wins, what moves have been made? We should be able to kind of print out a makeshift board, right? And it should probably look something fairly similar to this. I should have drawn it out before we started class. We should have two different lines. Actually, let's make these underscores. Let me zoom in a little bit. The board might look something very similar to this. These are underscores, right? Uh, space, space. I'm gonna use X's for now. X space space pipe space space X space space pipe space space X, something like that. I'm kind of just drawing it out to figure out like how do I want this to look like. Space space X space space pipe space space X space space pipe, right? Uh, so as I'm trying to kind of create this, I'm starting to visualize how my board should kind of look like, right? How a row should look like. A row will consist of three different possible strings that are separated by pipes. There's spaces in between. After every single row, I should have a row specifically with underscores that's going to represent the division from columns, or I guess rows. My apologies. Uh, so I should probably have some kind of way to display this board so the player can visually see what is the state of the game, right? Imagine trying to describe this to somebody. Um, so we might want to create something that's going to display the board. Think back to yesterday's assignment when we displayed the inventory, right? Letting the user know what is currently in the inventory, or letting them know the current weights, current volume, inventory slots. So we can create some kind of display board method, right? What class should the display board method belong to? Now, a trick question. If I had a class that had a method called display board, who would I want to give this class to?
The game.
You could, you could. Um, I'm not gonna say it's wrong or right. If I was making it, I would probably give it to the board. Um, I would probably give it to the board to show me to display it for me. The game, if I was to create a game class, which I highly recommend, encourage, right? And you should all create a game class. This game class should manage surface level tasks like create the instances of the players, right? Create the instance of the board and then run some kind of iteration that lets them go through the motions of all right, it's almost like a referee or a mediator, right? The game class should be like, all right, he's first and you're second, right? And then once he's done with his turn, then we're gonna switch him up. And then if he chooses and so on and so forth. The moment a player makes a game, I'm going to tell the board, hey, make sure update this part of your board, right, with this method. So the game class would probably be like the mediator or the referee of the other objects that we're going to have to create. So you should have some kind of way to represent your game, uh, and it probably a good way to create individual classes, maybe one for the board, right, and one for the game itself to keep track of the loop or the state of where the game is at, the progress of it. Here's a hint, right? Use a list or another appropriate data structure to maintain the state of the board. If I wanted to create this board, let's get some hints in here. What do you guys recommend? Let me hear some recommendations. How would you possibly tackle the display of this board?
Is it possible to maybe do a string?
Yeah,
Yeah.
maybe it'll probably be a string. How would you possibly do this string, Michael?
Ooh. Uh, hmm.
Yeah, the actual output at the end of it should end up being a string.
Maybe a
Um,
formatted string?
Yeah, maybe a format string, an interpolated string. Anybody else wants to add on to Michael's idea?
And we're talking about just adding to the board, right? Or how to
Right.
decorate it.
If we want to create some kind of method that's going to display this board for us, um, Michael mentioned maybe creating some kind of interpolated string, which I think is a good idea. Would you, how would you do that? How could you make sure that this interpolated string, and what do we know about interpolated strings? They typically take in some kind of variable that holds a value in it, which is what we try to tie in inside of a string. So there's probably going to be some values in here, right? The X's or the O's, whatever uh, is actually supposed to be here, these could probably be variables, right, that are going to be interpolated into the string itself. Um, so yeah, so you're on the right track here. We might want to make some interpolated string. Now, what about these values themselves of what should be going into each quadrant here?
What do you mean?
Yeah, like so, for example, if you want to ensure that you are able to identify these blocks, like if I told you, hey, Kevin, I want you to tell me the state of every single block within this hashtag, how would you do that?
Wouldn't you put like a like set a flag inside each of those squares, whether or not if it's X or a O?
Okay, we're on to something. All right, that's some progress. We yeah, I'm not too familiar with the verbiage you're using, Kevin, about flags. I'm assuming you're referring to maybe create some kind of conditional statement or if else statement where we're checking if something is an X or a no. Is that correct?
Correct. Yeah, that's what I'm saying.
Right. Yeah, that's definitely one way of doing it. But you're gonna want to show this over and over again, right? And then every single time a player makes a new move, we need to be able to update one of these areas, right? And then once you update it, you want to display the board again. How can you track the state of your board without losing the values that's supposed to be in here, without getting lost?
I was gonna ask where, not to get completely sidetracked off this. We're building this in the HT like on like a website like or through HTML.
Negatron, Batman, we're doing this in Python.
Oh, okay. So in the terminal. So we're gonna be displaying it in
Yes,
the
sir.
terminal.
Yes,
Okay,
sir.
gotcha. All right. So if we're gonna be displaying it in the terminal, then we would want to have like I know Python has like an input command
Right.
and like it allows the user to put like a certain input. So maybe we can use like for each cell of the board. So I call them like cells. For each
Yeah.
cell of the board, like basically, watch if this cell is updated with either an X or a O, and then like place it there. Correct?
Okay. Yeah. We're something like that. Yeah. The concept is there. Check the cell to see if it has an X or an O. And that brings up another question. If there's already an X and O there, probably shouldn't you shouldn't update anything there. Um, so I'm gonna give you guys a hint of how we can do this. Instead of thinking of this way, I want you to think of your keyboard, your keypad, 789. Give me a second. 789 four
4,
five
5,
six
2, 3.
1 2 3. Right? We can probably just use like the number keypad as a way to represent each square within um our tic-tac-toe board. There's one way of thinking about it that we can use it to reference. Um, Now, with this in mind, right, we have a row with 7, 8, 9. We have a row with 4, 5, 6, and we have a row with 1, 2, 3. If it makes it easier to really understand the concept, when we go to create this board, you can absolutely just replace what's supposed to be here with the actual values as a default if it helps you conceptualize what should be here. Now, we need some way to track what is actually being done. Now, there's a couple ways that you can do this, and I feel like you guys are leaning more towards the more manual side. I'm assuming you guys are thinking loop through a string and then check through every single character, and if the character is equal to an X or an O, then that means that's a value or something along those lines. Uh, Here's another hint. What kind of data structures could we use that we can probably create what's called a matrix? Who knows what a matrix is?
Like an array?
Like an array, right? Nested arrays. Could we possibly use nested arrays? Could
Sure.
one array represent a row, and then another array represent the second row, and the third array represent the third row? And could maybe index 0, 1, 2 represent the columns? Column 1, column 2, and column 3, right? So maybe something like this, where we have, we'll start from top to bottom, 7, 8, 9, 4, 5, 6, 1, 2, 3. How does this look? Thoughts?
That's probably how I would do it. I would keep the visualization separate from the game logic.
Right. And if I told you, Daniel, to print out the board, how could you use these arrays to print out this?
You would just call into the array and then go into that specific block that you want to print. So that array spot 0 would print 7, 8, 9. That array spot 1 would print 4, 5, 6, and so on.
Right. Remember, Daniel, I want it to look just like this. You're not going to print this out. You're going to print this. Right? It should look like a tic-tac-toe board. We're not going to be lazy and just have numbers. We're going to have the dashes, right? The cross sections. So we can give a better visual representation to our user. All right. So we're going to want to create some kind of object, or specifically, we want to create a class. Right? We're going to define a class that should be able to have a method that's going to run and display this form. If I have a board class, what type of data attributes might I want to give this board?
So if you have a board class, what kind of data attributes would you need, or for this?
Or data fields, data members, whatever you want to call them, data attributes, right? The variables where we assign values like name, like we did yesterday, like name, weight, and volume to our inventory items.
Clear XO.
Clear XO. What do you mean clear?
Like if a move hasn't been done there yet, there'd be a value, and then once a move was placed in that slot, you would record it as either an X or an O. That way you can check later, make sure you don't use the same move on a spot, and also for checks on if you've got 3 in a row.
That's a very good point that you bring up, Nick. How do we know who won? Right? You're bringing up, check the X's or the O's, and then check combinations. We could give that to the board. Could we create a whole different class to handle that, or maybe a whole different method to handle that?
Yes.
Right. We could absolutely create a method that checks possible combinations. Right. Checks whether the quadrant 7, 8, 9 all have the same value, or 4, 5, 6 all have the same value, and so on and so forth. Or check if the item at index 0 for the first list is equal to the item at index 1 for the second list, and also equal to the item at index 2 for the third list. Right? So we're gonna want to be able to check these different combinations and see if we have a winner. Right? And then also check what type of number was it, is X or is it O? Who won? So we're gonna want to do stuff like this. All right, so we should be able to have some kind of game board representation. We could use a list or some other data structure that you feel comfortable with to maintain the state of the board, right? Um, and then we want to have player inputs, right? The player should be able to enter a number 1 through 9 corresponding to the board position they want to play. So if I ask the user make a move and he tells me 8, I should be able to update whatever is on the square on the 8 section, right? Valid moves only. We should not allow a player to make a selection for a board square if there's already a move in there that was made. Right? We're gonna want to create some kind of wind detection. The wind detection, who's gonna have this? It could probably be a board method or a gain method. I'm gonna put question marks here because I'll leave it up to you to decide who do you want this to do this. Or you can create a completely different class, like check winner class, and this class takes a board object and checks the state of the board. So there's different ways that we could possibly approach this. For the valid moves, who can will probably have the responsibility of checking what moves are valid?
I would say the game itself.
Yeah, maybe the game. I think the game, since it's going to be the referee or the mediator, the game class will probably take care of this, right? The game class could probably double check whenever a player makes a move during their turn, they verify to ensure that it's correct. So maybe the game class, where should player input be handled, and what class should this probably be handled in?
Um, for the player input, see, for me, it's a toss up because it makes sense to put it still in the game class.
Yeah, why not? Absolutely. Now the player class, because you might think to yourself, why not the player? The player doesn't have to have anything complex. It could have just two different data fields. It could just have like, its name. Are you X or are you O? One or the other. And it could have another variable that's gonna be winning streak or total wins. It could be just that. It doesn't have to be anything complex. We just want the reason for why we are reading classes is to keep the code organized. But it doesn't have to be an in-depth class that does a lot. It could just have something as simple as whoever it is. It could just be a name and how many wins they have. Yeah, so absolutely, we could definitely give the game class the method to run the player input. Um, who should handle uh to recognize when the board is full with no winner and display the appropriate message?
Recognizing the board is full. So the board,
Probably the
just
check winner. If
Yeah,
it
check winner.
if it ran already so many times, then there would be no possible winner.
Right. If there's already been 9 turns, that means that 9 people, or there's already been 9 decisions made. Therefore, there shouldn't. If there's not a winner yet, then that means then it is a draw, right? So, the check winner system can also do that. We could give it to a check winner class, or we could give it to the game class as well. The game class could possibly be tracking some kind of variable that checks moves made, right? How many moves have been made throughout the entirety of this game loop, right? So something like this. Turn management. alternate turns between player X and player O dynamically. Who would be keeping track of turn management?
The game class, because they're like our referee in a way.
Right. The game class. We can have whenever the game class gets instantiated, they will have two. They can have two data members. One will be player X. One can be player O, and then we can have another data member that's going to be, uh, current turn. And by default, maybe we can start with player one, right? And then every single time this game loop runs, we just alternate whoever is the current person, uh, who is playing, right? We mentioned the user-friendly interface. Display the board state after each move in a way that's easy to understand. Who should show me their board?
The
What
board.
class? Yeah, the board should tell me what the state is. Board class. And then finally, game end notification. When a game ends, who should keep track of who's winning and who lost?
Would it be check winner?
It could be check winner class, or it could also be the game class. Either or.
I was thinking just now too. Maybe the check winner. Um, my brain just kind of just stopped for a second. I'm sorry. I was saying,
That's okay.
yeah,
You
maybe
might
the
ask
check.
yourself, does it have to be a check winner class? Why can't it just
Yeah,
be a method, Roger?
yeah. I was gonna say it could be a method. That's what I was actually about to say.
It
Like, could it be a
absolutely
method?
could,
Yeah.
which begs the question, why choose one or the other? Why would we make a whole class over a a method? And that leads to other thought process, but really it would have to come down to what is the scope of your project, right? Um, if you have, and we're just using, I'm using games as an analogy, right? Think about games. Uh, Games might have different systems. We might have like, a system that checks when something collides with something else, a system that keeps scores, a system that keeps records of the players. We might have different systems that handle maybe gravity. We might have a system that specifically handles the gravity of a player. We might have systems that handle the physics of the game. So it would depend on how big the scope of your project may be, right? If you have a project that's going to require like very specific systems like this, it might just be better to put it in a class where it's away from um, a specific class. For example, if you know that there's going to be multiple things that's going to have gravity affected onto it, you might not want to create a gravity method because that means you would have to give this method to every single person you create. Why not just create a gravity class, right? And then give this to whatever object is being instantiated, right? So that's how you determine that. Like, should it be a class or should it just be a method? It's going to depend on the scope of your project. If you're going to require this later on for something else, then it might as well just be a class so you can create an object version of it, then create a method. But you're absolutely correct, Kevin. We could most definitely just make it a method and probably give it to either the game or the board, one or the other. I don't think there's a wrong or right answer here. Uh, does that make sense?
Yeah.
Right. Okay. All right. So what we're gonna do for the next 15 minutes, we're going to give this a try. The first thing I want you guys to take care of is I want you to create the board class, right? Your task for right now is going to be create a board class that displays the board in your terminal, right? Your board class should have it should have data members. The data members is going to be for your rows. You want to either make 3 individual data members for each row, right? So either 3 data members for each row or 1 data member for all 3 rows. right? So as I mentioned, you can create something like row one, and it's just one list for the top row. Row two, and then create one for the row two, and so on and so forth. Or you could have one big data member that has nested lists within it. Whichever route you decide to take that's easier for you to conceptualize, by all means. After you create your data members, you should have a display board method. And this is going to quite literally print out the board on your terminal. Right? And we'll take 12 minutes. Time is 6:08. Let's go ahead and come back at 6:20 and give it a try. All right. So let's take a look at this. We're going to create our class for board. We're going to define an init method that's going to take itself, and we are going to leave it without being customizable. The moment a board class is instantiated, what I want is for it to already have 3 different data attributes or data members, which should be row 1 is equal to, and then we are going to do from top to bottom, we will do 7. We're going to use strings. Should we use strings? I guess we can do 7, 8, 9. If I get any issues, I'll make it strings. We will then create row 2, which will be 4, 5, and 6. And row 3, which is going to be 1, 2, and 3. So when I create this, I should already have 3 data members instantiated, right? I should not give the ability to my user to create a customized version of the board. This board will only have these 3 data attributes by default. And I'm going to create a method here. You can call it display board. I'm going to say draw board. And it's going to take in self and nothing else. And you can quite literally, to display this, you can do something, because it's only 3 different values here. If it was like 1,000 different inputs, I might want to make it a little bit more dynamic, but I can just simply say print, and then I'm going to say space, space. Actually, there should be a formatted string. Space, space. Self dot row 1, index 0. Space, space. Pipe, space, space. Self dot row 1, index 1. Space, space. Pipe, space, space. Self dot row 1, index 2. And I messed this up because I did not put these here. And then let's finally delete these. And then space, space for good measure. And copy and paste. Except this is going to be 2. This will be 3. This will be 2. This will be 3. 2 and 3. Right. All I need to do is be able to show my board on my terminal and have the respective values that are in my row be here. Now, I'm going to have to add something a little bit, but let's make sure this is working as intended. I'm going to create a board. So I'm going to say board 1 is equal to board. And this is going to create that instance, that object of my board class. And finally, I'm going to run the draw board method. And we can run this. I am inside less than 0.8. Python, tic-tac-toe, .py. Okay, and it's not exactly how I want it. What am I missing? I am missing my pipes. 1, 2, 3, 4, 5, 6, 7, 8, 9. I think it's 9. Let's see if this does what I want it to do. Oh, 9. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 6, 7, 8, 9. 6, 7, 8, 9. There we go. We are starting to look like how I want it to look. Awesome. There we go. There's a little makeshift board, right? That pretty much accurately represents what this looks like. 7, 8, 9, 4, 5, 6, 1, 2, 3. If I wanted to, I could delete these, right? And I could make these essentially empty strings. Right? And it'll probably still do what I wanted to do. It's just not going to be as pretty, right? But let's go ahead and do this. This will make it easier to visualize as I'm working with it. I can always come back and polish this out, right? But nonetheless, here is my board, 7, 8, 9. Now that we have something that we can visually see, the next step that we're gonna do is going to be to create a person class. This person class is going to have data members called, let's say, we can do name, right? Name will either be X or O, right? And how do we determine which is which? We could potentially create two different classes. One that is maybe like player X class. We can do a player X class where the default is X, right? And we could do create a player O class. These are just ideas where the name could be O. So when you go ahead and instantiate player 1 and player 2, you're going to call their respective classes. Or if you want, you could just make one player class and then you give it the option to pass in an argument of the string of X or the string of O, right? And then assign it to the name data attribute, right? And then what I also want you to do is you should be able to give it a total wins, and you should start at 0. Total wins is going to start at 0. The reason for this is at the end of this, we should be able to give the ability to maybe do best 3 out of 5, right? And then we can keep running this game, even though maybe player 1 wins, they don't win right off the bat because they need to win 3 times out of the 5 games. So maybe having a data attribute like total wins can allow us to do that. So you're going to create your player class. You can either create 2 different player classes, or you can create one that takes in the input for X or O, whichever one you prefer. I feel like this what this does, it prevents the user from making any kind of input, makes it a little bit more abstract, right? All you know is that player X is going to return to you a player object with the name of X, right? And that limits the player from messing with anything that shouldn't be messed with. All right. After you create your player class, what you're going to do is you're going to create a game class. Now, the game class is going to have some interesting features. Your game class within the init method, so essentially data members. Its data members will be player 1 object, player 2 object, player, no, not sorry, board object. And then you're also going to have a current turn, or you could do current player turn, whatever you want to call it, to track whose turn it is. Starts with player 1, right? To keep it simple. Something like that, right? Now, for methods, we should have a run method. This run method should be able to start a while loop, displays the board, asks the user for input, update the board. Now, there's going to be some more what's the word I'm looking for? It's obviously going to be a little bit more specific than this, right? But the first thing that we want to do here is just make sure that we're able to get this game running. We're able to display the board. We have our players, and we can update the board. Simple as that, right? Nothing too crazy. Don't bother checking whose turn it is. Don't do anything crazy yet. The only thing you want to do in this run method is just have a while loop that's going to show you the board. It's going to ask the user for input, and it's going to update the board, right? The while loop should be, for now, we're going to set a condition. Running is equal to true. That's going to be used for us to track the while loop, right? We can do something like this. And then I also want you to create, and the data members, we can do something like total turns is equal to 0. Yeah, actually, let's go with this. Let me take that back. Instead of doing running is equal to true, what I want you to do is start a while loop while running is less than 9. Right? What that's going to do is it's going to allow us to make 9 complete turns and fill up the board. Right? We'll keep it very generic, very simple. We're going to have a total turns data member that starts at 0. And the run method is going to start a while loop that's going to run while 9, or while the total turns is less than 9. We're going to display the board, ask the user for input, update the board, and then update total turns after every iteration. So we can break out of this while loop. Right? So we instantiate a game object. The moment this game object is instantiated, it will already should have a player 1 object, a player 2 object, and a board object. Right? The current player should be set to player 1. And total turns will be 0. After you have instantiated your game object, you're going to run the run method, which is going to start a while loop while total turns is less than 9. That's going to make this run method run 9 times. Every single time it runs, it's going to show you the board and ask you for inputs. And then you're going to update the board accordingly. Now, what are we missing from here that's going to update our board?
The player input.
We got the player input, but what should update our board? We might want to create a method for our board class, right? Our board class should have a update board method that takes in user inputs, updates the board dependent on the user input that we receive. So if the player gives you the number 9 or the number 8, when you go to update the board, you need to call update board with user inputs. Right? So we want to give our board class a method to update the board. Do I have any questions? Time is 6:36. Take a 10-minute break. Come back at 6:46, and then we will go until 7:05, and then we'll come back. Sound good? All right. I see Dominic. You're like, God dang. Stressing. Be working.
All right. Yep, here I'm at.
Okay. Yeah, so let's see. The run method put pass in line 93 so you don't get an error. Continue won't really work right here. Why is it still giving me error? Oh, I'm assuming because
I don't have anything here.
Yeah.
I mean, I haven't run anything yet, so.
When an object is instantiated, right? When you call the class for an object, what do we say automatically runs the moment you try to create an object?
What do we say automatically runs the moment you try to call an object?
Yeah, so whenever, like what you do here, when you do tic-tac-toe is equal to board, you're calling the class name, right? Board.
Yep.
What method runs automatically the moment you do that?
The init method?
Right, the init method. The init method by default will automatically run.
But I
So
want the game board to run.
hold on, we're getting there, right? So
Okay.
when you instantiate a board object, it's going to run the init method. So let's go ahead and navigate back to the init method below, right? So it's going to run this. The init method is just a function. So it's by default running a function. It's making this function run. So when it runs this, it's going to run whatever you put in here. So you are able to make this function create another object for you as well. Right? And that's what we want to do in our game. We want to create a board object and our 2 players. Right? And we're going to assign them to a variable, which is what we call a data attribute, right? A data member. So whenever we create any version of this game, it by default should run this init method that's going to create 1 board and 2 players.
Now,
Exactly the same
okay.
way that you are creating tic-tac-toe down here and saving the object into a variable, that's what you're doing inside the init method. It's the same concept. The only thing different is it's inside of a class, right? That's the only thing that is different here. Really,
I see. Okay.
when you think about a class, imagine a file. Imagine class is a file. That's all you're doing, right? What happens when you run a Python file? It runs your code. And that's what is happening here. It's running your code. From top to bottom, it's going to run these functions,
I
right?
think it's mainly the syntax that like I'm struggling with. So here, am I writing like player X?
So the syntax here, the data attribute, that's your variable name, right?
Mm-hmm.
So yeah, you want to call it whatever you want to call it. You could call it player X, you can call it player Y, you can call it player one, player two, whatever you want to call your variable, or in this case, your member, you can call it whatever you want. So yes, you can say self dot player X is equal to, and then you want to create the player object.
But when do I want to start using like calling on these methods up here, these classes up here into my game?
When it's running.
So in the run.
Yeah, and the run function is going to start this while loop that can run other functions as well. Think of it like, what's the way I can explain it?
Well, my question is like, what's the point of this here? Like, why do I need to write, like, why do I even need to make this init method here if I don't like the game? I have the players created here and here. I have the board game created up here. Why don't I just have class game be the run?
Right. So that is the whole concept of classes and objects is that you are able to format and organize your code into classes. So yeah, you absolutely could just put all this stuff in here in a regular Python file from top to bottom, right? The beauty of classes and objects, it lets you reuse code in other places, right? So in theory, you can create 100 different versions of game, right?
Yeah.
Because all you have to do is define it once and then just call 100 different game objects. That is the point of creating classes. It lets you organize your code inside of a class that you can just keep calling over and over again as you need it.
So I guess like, what am I doing here? Like, it's like, what is this doing? And what am I writing here?
Let me show you with TL Draw. I love TL Draw. It's a great, it's good to see visually. I'm opening it up. And I'm sharing. We should all be seeing my TL Draw. Is that correct?
Yep.
Okay. So we could do something like this, right? You could do, let's say, you could say, how can we do this? Hmm. How can I do this? So first and foremost, we can do, we know the concepts of functions, right? We know that. Uh, we could most definitely do something like create a function called mean or average, right? We know this, and we can take it a list of numbers 1, 2, 3, 4, 5, 6, 7, 8, right? As an argument. And then what we can do is to the way that we get average is that we have to sum up everything. So we have to something like sum is equal to you can do something like sum is equal to 0 for num and actually let's change this. Let's call this list of nums for num and list of nums. And bear with me. Sum plus equals num. So this will end up getting you the sum of all these numbers. And then we can say average of nums is equal to sum divided by the length of list of nums, right? We know how averages work, correct? We know how this works.
Yep.
But what if we want to, instead of having to manually do like sum and have to do a for loop, we create a different function called sum that takes a list of nums. And we do in here, sum is equal to 0 for num and list of nums. Sum plus equals num. Return, I'll fix it. Return sum. We're able to do stuff like this where instead of having all this extra work in here, we just create a function, sum list of nums, that we can call inside of another function. Right? So that way we define this function once, and then we can use that sum function everywhere else. Right? Notice how sum itself is its own function. So that way we don't have to rewrite this every single time we want to add numbers, right? We add it into a function to organize it, and we can reuse this function inside of another function, just like we're doing here. I'm literally calling the same function I described earlier inside of this other function, right? Now, all this is all within what?
A class.
Not just yet. We'll get there in a bit. Main.py. It's inside of a file, right? You created this list for these two functions within this Python file. Now, what if you have to use sum multiple times in different parts of your code, right? There's a lot of math you work with. You work with a lot of different numbers. You're constantly using these functions, sum and average. So what we essentially do with classes is we create a class. We can say basic math. And we could define an init method. Jesus Christ, why is it not? There we go. It doesn't like, I guess that means bolded. I don't know. Self list of nums. Self dot list of nums is equal to list of nums. And then inside of this class, we create methods that belong to this. All we just did was encapsulate what you normally already do inside of a class. And now we are able to do something like my basic math is equal to, we call the basic math class. And basic math can do something like sum of lists is equal to my basic math dot sum, which is one of the methods it has, right? So what classes does for us is we're able to format our code into one big kind of data structure that we call classes, right? It's the same as putting all this in just a file, right? The same concept. Classes is all it's doing is organizing it and encapsulating it somewhere that we can call repeatedly in other places. That's all a class really is. Notice how this main.py file has two functions created in here. Same concept in here. We have this basic math class, and it has functions inside of it. Does that make sense? And now, if I wanted to use these functions somewhere else, and they only existed in a file, I would have to import them from main.py import sum. Right? Have you guys seen this before? From main.py import average. The same way that you guys are importing random, import random, right? These are functions that exist in a different file, and you're trying to import them to use it. Instead of doing all that, we just create them all in a class, and they're encapsulated within here. Does that make sense? These are the same thing. All classes do for us is provide some kind of format where we can put multiple things together. We're able to have variables, right? We could have a variable in here. I should have done it from the beginning. Num lists is equal to 1, 2, 3, 4, 5, 6, 7, 8. Right, and then when you go to call the function, you say sum, and you pass in num lists, average, list, or num list, my bad. Right, here is the value or the variable we created, which is a list of numbers. We have two different functions that do math with this, and then we pass in this list of numbers into each individual function. That is the same thing as saying this, right? The init is able to hold a variable, just like this file, we're able to create variables in it. And then we are able to pass in, actually, let's remove this. If I want it to be exactly like how this is working, then this should be self.list of nums. And this should be self.sum. And I'm taking the data member of list of nums. Are you seeing the similarities between all this? Right?
Yeah.
The same thing that I would do in a normal file of Python, where I'm creating a variable of my list items. I create functions, and then the same variable I used earlier, I'm pushing them inside of the function and calling it. I'm doing all that in a class where the variables are here in the init method, right? We call them data members, right? In a regular file, we just call them variables. But the naming convention inside of a class is a little bit different. But they're the same thing. But like fundamentally, they're the exact same thing. In a Python file, we have variables. Inside of a class, we have data members, right? Just the same way that we have functions in a Python file, we have methods in a class. So classes just allow us to structure multiple different variables and functions within one consolidated location. Does that make sense? That
Yeah.
is what that is literally all we're doing here. So go with this in mind, I want you to return to your file or your code. Let me go. Can you go ahead and share it? Right. So, like I said, think of game as a file. Inside this file, you're going to create some variables. Those variables are going to be objects that you're going to create. Right. So you want to create two different player objects. So yeah, you should do player X, and then you should create a player. Yeah.
I don't want to capitalize it.
Well, that's the name of the class, right?
Okay. So, okay. I see.
Yeah, so you have to call the class name. Exactly. Yeah. Awesome. And because these are classes, they require parentheses afterwards. All right. And then one last thing, you typically don't want to call a variable the same thing you want to call a class, right? So you could do all lowercase if you like, player X or player underscore X, whatever makes you feel better. But we're creating variables here that are objects. That's all we're doing here. And then once again, thinking as game of it being a file, inside here we're going to create some functions, right? But here we call them methods. And this function should be able to start a while loop, right?
Okay.
The same way that whenever you're creating a Python file, Michael, and you create a counter, that's what we're going to do as a data member, right? We're going to create the current turns or total turns, whatever you want to call it. Yep, we're going to create a board as well.
And I have moves here. Do I need to have like another counter on the outside? Or are you talking about the player? Like I have player wins up here.
Yeah, I would probably put moves over here as its own data member. I would call it not player. I wouldn't call it moves. I would say maybe something like max turns or total turns.
Okay.
Make sure you also use self, right? Because it's within a class. Self dot max turns is equal to 0. Yeah, perfect. And then we can remove this from here, and our while loop will be while self dot max turns is less than 9. Right? So these are just essentially just variables that we created, and this is a function that we're creating within here. That's all it really is.
Okay, and I want to, so this, when I call on game board, or this is going to run, it's going to display, it's going to run through all of these.
Yeah, okay. So game board is currently assigned, go back to that. Game board is currently assigned to self.game underscore board, right? So this, as we already know, is an object of board. And board has a couple functions, right? Methods. One of those methods is display board. So if you want to use this method, you have to call self.game underscore board and then call the function or method that it has, right? So
And I do
within
that here
here,
in the run.
right, correct. The same way that whenever we created a sum function and then inside the average function, we call the sum function, right? You remember that, how we just did that right now? That's
Yep.
what we're doing here. We're making this run method call the display board method from board, right? We're just leveraging the fact that board has access to this function.
Mm-mm-mm. Do you just do it like a return function, or you just say self dot
Yep.
game board?
Self, you call the variable, which is self.game underscore board. Yep. And then you use to make it use its function, you have to use dot notation. So we say game board dot and then the name of the function, which should be, I believe, is display board. Oh, I don't know what you called it.
Um,
Oh, you call it game board. Yeah,
game board. Oh, maybe I'll change that to
yeah.
something else.
Either display or draw board.
Display board.
Just like that. And it's gonna run that function that belongs to game board object.
Oh.
Get off me, punk. Out. Out.
Find display board self. Oh, that's because I have. Tic-Tac-Toe game board. That's because I just changed this. Okay. All right, so we get my board here. Okay. Sweet. Thanks.
Yeah, no problem. Let's go ahead and continue.
Oh, do you want me to keep sharing?
No, I'll share.
Okay.
Uh, so we have the board. The assignment was, can everyone see my VS Code?
Yep.
All right, cool. We have the board, but now we need to create player. So we're gonna say class player, and we're gonna give it an init method. And it should take a name, right? So whenever we create this player object, it's going to assign the name, and then we're going to set total wins is equal to 0, right? So no player should start off with any additional uh wins. It should all be 0. And when I call this player, I should even give it the X or the O. Or we can do player X and then not even create one player. We'll just say this one is going to be X. And then we can do the exact same thing, but for the O, right? Player O with the name of O, right? Two different player classes. We could do this, or what's another way that I taught you guys yesterday that we could have done? Now, this is a little overkill, but we could have definitely done something like class player. And then we could have defined our player self dot underscore name. And let's give it name here. And we could have done something like this, where we inherit from player. And then we can use super init, where name is equal to X. And then the player O can inherit from player. And we hard code super init in here, name is equal to O. So there's a couple ways that we could have done this. This we create default for player and we inherit from it so we don't have to do anything extra. And this comes in handy when you do stuff like giving a class multiple methods, right? This is one way of doing it. I just want to show you how you would do it if you want to inherit. But let's go back with the other way because it's less confusing. What should player be able to do? It should give us the name, right? Because we need to know the name of the player when I make a move. Why? Well, because the board needs to know if it's going to put an X or if it's going to put an O on the board when a player makes a move. So we need to be able to check the name of that player, right? We should say return self dot underscore name. And the same thing for player O. We're going to do a getter function for name. Return self dot underscore name. This gives a function to our player class that's going to allow us to get back the name that they have, right? We need this function so our board knows who is making a move. Any questions on the player X or player O before I move on? Speak now or forever hold your peace. All right, cool. So we got the player X and O. What was next? We need to create our game class. So we're going to say class game with the init method. It should not take any attributes. And as we've mentioned before multiple times, when you create an instance of a class, the method that runs automatically is the init method, hence the name init for initialize, right? Python will automatically auto run this function here or method, right? And when it runs, I want it to create player 1. And I want to create player 2 as well. Right? We defined their both X and O, so we don't have to keep giving arguments. We'll just pass it. It already has hard coded what their name is. So we're able to just call player X, opening close parentheses, player O, opening close parentheses. And as well, when we create this game, our game should automatically create a board. And I'm pretty sure board has nothing. Yeah, cool. Awesome. Now, our game should have a function that we can run. Oh, my computer's about to die. Stand by. I underestimate the lifespan of my laptop. All right. Our game should have a function called run. This function is going to start a while loop. And as we mentioned before, that while loop needs to run for a total of 9 turns. So I'm going to create another data attribute for our game called self.max turns is equal to 0, or I guess total turns. Total turns. And I'm going to say while self.underscore total turns is less than 9. I want to do the rest. Well, what do I want to do? I want to display my board. I want to show the status of what my board is every single time that a new turn starts. Well, how do I display my board? I think we created a function for it. Yeah, here we go. Draw board. I should be able to draw my board on the screen. So when a new turn starts, the first thing I'm gonna do is my board is going to draw itself. So I'm gonna say self dot underscore board dot draw board. Right. This data attribute self dot underscore board is a board object, and I know that my object has a function called draw board. Next, I need to ask my user for inputs. Right. We start the while loop. We display the board, and then we have to ask the user for input. What move do you want to make? So I'm going to say user input is equal to, and then I'm going to call the input method. And I'm going to say choose or make a move. Make a move. We'll keep it simple for now. We're going to come back and we're going to update it a little bit. Right now, I just want to make sure I can visually get my game running and I'm seeing some input in my terminal. Right, but I'm going to make it ask me for a move, and then I'm going to be prompted for some input. I'm going to give that input, and it should take it and save it into the user input variable. Now, once I give my input, I need to be able to update my board. But as it stands, my board has no way of doing that, right? As it stands, my board has no way of doing that. So how do I do that? Well, I'm going to give a update board method to my board. So we'll say define update board. And this method needs to be able to take in whatever decision my user made. And I need to know the name of my user, right? My board needs to know if it's an X or an O. So when it goes to update it, it can put the X or put the O. So with that in mind, I know that my update board needs 2 arguments. One is going to be user input, and the other one is going to be the player name. Or I'll just say player. All right, and I'm going to add a keyword here. That player is supposed to be an object. That'll remind me that it has a method, and user input is going to be a integer, right? Because they're going to choose a block from 7, 8, 9, 4, 5, 6, or 1, 2, 3. Right? So whatever they give me, that's what I'm going to use to figure out where they want to make a move at. And now we start essentially a series of if-else blocks, right? We're gonna go. How do we do this? Well, if they give me a number that's either 7, 8, or 9, I know I need to update row 1. If the number is 4, 5, or 6, I need to update row 2. Or if the number is 1, 2, 3, I need to update row 3, right? Because that's how this works. How can we do this? Actually, let's change this up. I'll call this row 3, row 2, and row 1. Nah, never mind. Doesn't really matter. It's just kind of, I'm trying to not confuse myself, but it's okay. Row 1 will take the top part of my keypad. And here's where I'm going to check. I'm going to check the user input. If they gave me a number greater than 7 and less than 9, I need to access row 1. Right? If user input is greater or equal to 7, or, oh no, it should be and user input is less than or equal to 9. Then I do one thing. If user input is greater or equal to 4 and user input is less than or equal to 6, then I'm going to grab row 2. If user input is greater or equal to 1 and user input is less than or equal to 3, then I'm going to do something else. And if it doesn't match any of these ranges, I'm going to say your input is out of range. Choose a number between 1 and 9. Or choose a number from 1 through 9. Better way of writing this. Right, does this make sense so far? Do we understand how I'm making these decisions? All right, cool. Because remember, I'm going to ask the user for input. They should give me a number from 1 through 9. I'm going to pass that into this method as well as their name to see what I'm going to do. But let's take it one step at a time. Let's handle row 1 first. If it's 7 through 9, I need to be able to grab self._row 1. Right? And it can get a little lengthy here. It depends how effective you structure this. I could say if user input is equal to 7, and then 8, and then 9, it get very lengthy. How can we do this? Who has a much more effective way of doing this?
So
I know.
Uh-huh. Update board. We're verifying user input is within our bounds, right?
Right.
User input is great. 7. Oh man.
I think I already know how I'm gonna do this.
Okay.
I think because it's row 1, if I want to grab the item at index 0, how can I do that?
Self._row 1 bracket 0.
Right. So there's a couple ways, right? And let me explain. If they give me an input and it's greater than 7 or 9, I could manually check if user input is equal to 7, if user input is equal to 8, if user input is equal to 9, but then it gets very complex. I'm gonna have multiple if-else statements. So what I can do instead is I can subtract, if I want to grab index 0, I can subtract user input minus 7, and it'll give me index 0. If I want the item in index 1, I can subtract user input minus 7, and it'll give me 1. If I want index 2, I can subtract user input minus 7, and it'll give me 2. Does that make sense? So all I can say is something like self dot underscore row 1 user input minus 7. Right? That'll grab me the index I am trying to update. Do we all understand what I just did here? Right? Instead of adding multiple if-else checks to see if it's 7, 8, or 9, all I do is I grab the input they gave me and I subtract 7 from it. And then that'll give me the index I'm trying to grab, whether it's 0, 1, or 2. And then right off the bat, all I'm going to do is assign it a new value. This new value should be the name of player, right? Because what is the name of player? It's either going to be X or O. So I'm going to say player dot get name, right? Because player is going to be either a player X object or a player O object, right? And as we already defined, we have get methods for both of these to grab their names. So this is going to return to me the name of whatever object I pass in here as an argument. Now, with that same concept in mind, let's do the other ones. Row 2, user input. Here is actually a little bit different. If I want to grab 0 and they give me 4, I need to subtract 3, 3, 2, what? No, I need to subtract 4. User input minus 4 is equal to player dot get name. And then I'm going to do row 3, self dot underscore row 3, user input minus 1 is equal to player dot get name.
Do you have to assign like a variable for basically to be able to use the getter functions inside of this board class because the getter functions are not in the class right now?
So I feel like you're no, I don't have to assign. Well, I mean, I do have to pass in an argument in here, right? This is a function, right? This function belongs to the board class. So this board class, when I call update board, is going to take an integer, which is going to be the user input, and the other argument it's going to take is the player object, right? That object is coming in here with functions already predefined, right?
Yeah.
Here's the player objects that are being defined. They were already instantiated when game starts running. Remember we defined that?
Yep.
So down here, I should be able to say self dot underscore board dot update board. And as I mentioned, I should pass in the user input. And I'm going to pass in either player 1 or player 2, right? Because these are the objects that have these methods. Does that make sense, Michael? Or am I still losing you here?
No, that makes sense. I think my question, like, so right up above it says self dot underscore player 1 equals player X. Like you're using that player 1, that self dot player 1 as a variable to pull
Yes.
in the class above of player X and player O.
Right.
I'm wondering why you don't need to do that up above in your board class where we're saying get name, but in the board class we haven't done a variable saying, okay, I want to use, is it because we're not calling on it until we get down to the game class and that has it already listed?
Right. It's just like a
Okay.
function, right? When you define the function, you give it some kind of parameter name. It could be whatever you want. It could be X. This could be X, right? All I'm saying is whenever I use update board method, this item here is going to be an object. And I know that this object should have a function called getName. Right? I'm not getting an error because my Python code knows there's a class out there that has getName. It's
Okay.
down here, right? So that's why I'm not getting an error. Your VS Code knows that somewhere around here you wrote it out,
Yeah, okay.
right? It's almost like me saying print my person 2 because I haven't written it anywhere. It's giving me an error here, right? My person 2 is not defined, but getName is defined. My VS Code knows that I wrote here that there is a getName method that belongs to a class. So it's interpreting, okay, I'm assuming you mean that you're going to pass in an object here that's a player, right? Because the only thing I read inside your code that has getName is this object, right? So your VS Code is aware that you wrote this already.
Okay.
Right? And that's why I'm able to use it here, even though I'm not calling this function yet, because VS Code knows that this actually does exist inside of my code. And I'm just not using it yet. Look, function getName. It knows the function. Look, player, it's a parameter right now, but it understands it's an object.
I see.
Right?
I see. Okay.
Variable player 1, which belongs to player X, right? So this isn't really intuitive though, or dynamic. I'm hard coding self._player1, right? This is not exactly how we want it to be. We essentially want whoever's turn it is. So let's go ahead and create that variable self._current turn. And to start off, I'm going to give it player 1 for now. Self._player1. Right? This is who's going to start off first. And I'm going to update this after this while loop. And you'll see how this works. But I should not hard code player 1 or player 2 in here. What needs to be here is whoever's current turn it is. And just like a counter that we're able to update after every iteration, we're going to update the person whose current turn it is after every loop. So that way, when their loop restarts, there's somebody else new within here. Make sense? So self._current turn is going to be passed into update board. All this is going to run. And then after it runs that, I want to, just for the sake of it for now, I'm going to go ahead and update my board or draw my board again so I can visually see what's happening. And then once that's done, I should be able to change whoever current turn is. So I'll say if self._current turn is equal to self._player1, I'm going to change whoever's current turn is to the other player. If it's not player 1, it needs to be player 2, right? Right, all I'm doing here is switching them out. If after this loop is done iterating, the person whose turn it was player 1, I'm going to switch it to player 2. If it wasn't player 1, that means it was player 2. Therefore, I should make it player 1, right? So I'm just switching here whose turn it is. And then what else do we need to do after this loop is done to make sure this while loop ends at some point?
Update your turn counter.
Yeah, update my turn counter. So I'm going to say self._current turn plus equals 1. And I think this should work. Let's give it a try. We might get some errors. I don't know. board1.run. Let's see how this goes. Ooh, there's actually an issue I have here that I didn't fix. Our update board is taking an integer, but our input, what did we say it returns to us?
A
It return
string.
it returns a string, so we need to typecast it to an integer. And now we should work. Board has no attribute run. Oh, my bad. I need a game. My bad. Game is equal to a game object, and then I'm gonna say game dot run. Let's try this. Okay, here we go. Make a move. I'm gonna say 1. Ooh, so close. I updated it, but I got an error on line 165. Oh, I said current turn. I should have been total turns. My bad. There we go. I was updating the wrong data type or data member. Make a move. 1. Okay, there we go. Ooh, it looks a little ugly. Let's go ahead and remove this draw board and run it again. Let's say 1. And here we see 1 was updated. Let's say 5. And 5 is being updated. Let's say 4. Let's go 6, 2, 9, 8, 7, and then 3, and it stops. Unfortunately, it didn't show it to me once I got the last one, so we'll have to fix that. A little bug. But up to this point, I was able to draw my board. I got a running game that alternates between players, and it updates my board. Maybe not exactly perfect. I need to make sure that if total turns is equal to 9, actually, I'll do that right here. If self dot underscore total turns is equal to 9, I want to display my board again. Self dot underscore board dot draw board. This should fix that. Right, where it didn't show it to me at the end. And I'll take it one line at a time. And there you go. So now when I'm done with my turns, I still see here that I made all the inputs and it showed me the very last input, unlike it did earlier. Do I have any questions so far? None. Okay. I got some for y'all. Okay, Michael, I see you unmuting your mic. What's up?
It's not so much a question about your code, it's just I'm having an issue, so maybe
Yep,
we could take a look at it and see. It might be something simple.
let's see it. I stop sharing. Floor is yours.
Okay. So I'm having an issue on line 101 where player X right here. I'm not really sure why, because I'm calling these just fine like you were doing here.
It says player X init missing one required positional argument name. You see it there in your terminal? Let's look at the definition of player X right there. You passed in an argument, so it's expecting you to give it a name, but you're also hard coding the name. So either assign self.name is equal to name or remove name as an argument.
Oh, I see what you mean. Oh, I see what you mean. Okay. This one needs to be,
Yeah.
oh, this
If
one's
you want to
next.
hard code it like mine, you need to remove the argument because it's
I see.
expecting one because that's what you told it that it takes.
Okay. Display board.
Game object has yes.
Oh, line 123. Don't I have display board somewhere?
Did you create? Hold on. Did you create? Go back down. Tic-Tac-Toe is an instance of game, but you're trying to use display board, which is a method of
I
board,
just want to do
not
run here, right?
Right. So there you go. You want to use the run method that belongs to the game object, which is correct.
Uh, let's see.
Player,
123. Run is not working.
no, the run's working fine. It ran here, but then inside of here, line 108, because run is gonna run this function right here. On
Yep.
108, it's saying, okay, you did the exact same thing I was trying to
Oh,
do.
I changed the names during. Yeah, I did.
Total turn. There you go. Let's try this. There you
Okay.
go.
All right.
It's okay.
Let's see.
111.
111
You're trying
update
to
board.
it's missing precision arguments, player choice and player. So the update board, it has to have two arguments. That's how we define it, right? We're supposed to take in whatever the player choice is, and we're supposed to pass in a player object. Do you remember that?
Yeah, I remember you doing it. How did you
Go to the update board method that you define right here.
update board? Yeah.
We have two arguments we're supposed to take: the choice and the object of the player,
Okay.
right? So you need to make sure you pass that in when you call it. So scroll down.
Player choice and player.
Player choice is here, and then you want to pass in whoever's current turn it is.
Where do you put that?
The update board, it's a function, right? You're calling the function. And the definition you gave this function was that it takes two arguments inside of them. There you go. Yeah, we're taking two arguments. The first one was the player choice, and the second one was the player who's currently making this choice.
I do current turn.
Right. Current turn will give you the
Whoever's
object of whoever you assign first, which is good. But that's going to be the second argument. What is the first argument supposed to be?
player choice.
Right. That player choice you define. Switch the player choice variable from capital P to lowercase p. Right. There you go. We don't capitalize regular variables. Okay, it's working.
What's gonna happen if we fill these all up? So 4 is still available, 6 still available.
8, 9, and 3. There, something is wrong.
What happens if I do it again?
Where did you
It
put?
just updated, yeah.
Yeah, the while loop isn't stopping like it should. Where's your condition to stop the while loop? And where is it in your function?
So while it's less than
There you go. All right, the flow of your while loop. Now it's gonna update every single time it runs one iteration.
10 run. What's wrong with this now?
It should be fine. Clear it, run it again.
One. I just ended it. Okay. That's not a big deal.
That's good. It's good for now.
It's good for now. Okay.
All right. Let's go ahead. I'm going to assign you the next item, and then we'll take a break, and you guys can work on the last piece. Go ahead and share my screen.
Okay.
Okay, so we got a pretty close game. It's working so far. We just gotta do a couple more things to make sure it's working how we want it to work. Who can think about some things that are wrong with our program so far? Or some bugs that we might encounter?
You can override the other player's input.
Awesome. So problems to fix is going to be you can still override players' choices. So that needs to be fixed. What's another problem?
There's no winner picked yet.
No winner, right? No winning combos. What's next?
On that same token, no draws.
Yeah, we have no draws. So no draws. I'm glad we're starting to see this. Okay, cool. So we can override players' choices. We have no winners. We have no draws. Is that it? And that's not a tricky question. I can't think of anything else. No winner, no draws. What else? Hmm, I think that might be it. Stretch go.
These are your nice to haves, right?
Right. You're nice to have if you can possible stretch go. Uh,
Maybe take
Water
turns
tower.
on who starts.
best 3 out of 5. Right. So tractor wins. You could do that. That's a nice to have. Uh,
Restart game.
choose who starts first. Restarts game. Do you want to play again? Option. But yeah, I think this is what we're going to do next here. Is to finish this off. We want to first and foremost, we should not be able to update a board section if there's already an X or an O. Now, with that in mind, I want to make sure I annotate this. If they try to update an already chosen square, do not take up the turn and let them continue to pick until they choose a valid option. Right? Because what's going to happen is if you set the condition like, oh, this is already taken, you might restart the loop and then it'll go back to the other person. And that other person failed to choose a box and then it'll waste a turn. So, in the event that they try to override a player's choice and you stop them and you tell them, hey, this box has been selected, make sure that you do not take up a turn and you let them continue picking until they choose a valid option. How you implement that is going to be up to you. We have no winner, no winning combo. This is probably going to be very tricky for some of you guys. Calculate all possible winning combinations. The no draws. If no winning combos and max turns exceeded, keep a draw counter / win counter. This will tie into the best out of 3 out of 5 if you want to do it. If not, you don't have to keep a draw counter or a win counter. That could be a nice to have. If you reach a draw, just say there are no winners. It is a draw. Do you want to play again? So I'll add it here or uh, display it's a draw and ask to play again. So whichever route you decide to go here, if there is no winning combos and the max turns are exceeded, you can either keep a draw counter and then reset the game and start again. That can get tied into the best 3 out of 5. Or display that it is a draw. Like, hey, this is a draw. Do you want to play again or not? And then you'll restart it all over again. However you want to approach this is going to be up to you. Do I have any questions? I'm sure Nick is going to enjoy playing with his daughter.
If I can get it working, she's gonna love it.
All right. So time is 7:52. Go ahead and take your last 10-minute break of the night. Upon return, get cracking. And we will start, we'll come back, let's say 8:45. Yeah, we'll do 8:45. So I'll give you guys enough time to do this because I know this winning combos will probably give you guys a hard time. I'll see you guys in a bit. Night.
All right. So let's start this. So we can play. So we'll get it to win. So we can see that. So player is gonna choose. We can see that it loads in like X right there. We'll do the second player choose somewhere else. Chose spot 5. Player X again is going to choose 2. Player O can choose 8. And then player X can choose 3. And then we have player X, you are the winner. But it keeps going to play your take return.
Okay. Where is a check in the winner?
Right here.
Okay. All right. That's a lot of information here, but I'll take it. So
Okay.
when it's done choosing the winner, what what is that exit that you have there? You're just exiting out from here?
I was trying to get it to exit the game.
Okay. So it's a function, essentially a method. How about let's return a value, right? We can return either true or false, right? If there's no winning combinations, then let's just return false every single time. If they want, so actually right there it should return true. So all that should be returned true, and then there should be one final else statement, or we're going to say return false in the event that none of these were winning combos. Make sense?
I think so. Okay. You're gonna have to say that again, I think.
All right, so all these are possible winning combinations according to you. Is that correct?
That's correct.
So if none of these are none of these are passed, right? None of these if else checks pass. At the very bottom, we should have an else statement that's going to return false instead, right? So if none of these combinations are possible, then we're just going to return false. Now,
Okay.
with that in mind, we should be able to go back to our game loop. And here, where we check on line 185 for winning combos, we're going to say if whatever comes back from winning combos is equal to true, then we exit out of the game, right? We can say return. So you can say right here, you can put an if statement. If
Oh, like if equals.
Yeah, if that is equal to true, because whatever comes back from the return statement is going to be a Boolean. So if it's equal to true, then we should be able to type in return here, and that's it. If this doesn't equal to true, then it won't ever come in here, and it's going to continue like normal, right?
What is this
Uh,
return doing?
right. So remember, in functions, a return statement brings you out of the function.
Okay.
Right? And it returns some kind of value. Here, we're not making it return any value, but what this is going to do is it's going to exit out of this function. Or you can also just say, we can switch total turns, make it equal to 9, and that'll make it fail as well. Either or, whatever we do here, we just need a way to break out of this while loop, right?
I see what you, okay, yep.
So if it's equal to true, it's going to return. If not, we're going to continue with our while loop like regular. So try this out now. Press Control C to stop your for loop. There we go. And then let's run it again.
Okay, 7, cool, 4, 8, do 1, and we'll do 9. Okay.
Sweet. Yeah, there you go. Okay. So for a final demonstration, Michael, now that we have a winning game,
Okay.
what were the three assignments? The three assignments that were assigned to you guys was first and foremost was we can still override players' choices. So show me where we are ensuring that we cannot override a player choice.
So this is the code I went with. I don't know if I actually tested it, so we can test it, but let me see what it does. So we can just, oh wait, I pressed the wrong button there. So we can do 7, and if player O, yep, says, please choose another spot, and it didn't override it. So it's still the first player's choice there. So if they
Sure.
choose 8, oh, that's the only thing, it skipped their turn.
Yeah.
Ooh, okay.
Okay. So we got some work to do, but that's okay. You have been working to a certain extent. You just have to make sure that we do not skip that turn. Daniel here came up with a really cool way to solve this, and it was by the ways of recursion. So, what we did here is if we are not able to pass any of these checks at the else statement down here, we're going to call the update board method again. So on line 84, we're going to call this function again. And this might be out of scope for you, Michael, because I know we haven't covered recursion. Um, so it's okay if you don't understand this yet. We'll get to recursion later in foundations programming. But as of right now, all we're going to do is we're going to call self.updateBoard. We're making the function call itself. And then here, what you're going to do is we're going to put a new user input and we're going to put the same player that's working. So we need new user input. The way that we're going to do that is between line 83 and 84, we're going to request input from the user again. So say new user input is equal to, and then we're going to invoke the input method. And then here you can say invalid choice. Whatever you have there on line 83, that print statement, you can put that string in here. It's going to make the user give you new input again while still in this function. You can get rid of line 83. And now we're going to call the function within itself. We're going to put in here new user input and then pass in the same player in here as well. So new user input comma player, that's as we have already established before. That's how many arguments this function takes. And this is going to keep running this until they find a valid input. Let's try this out. Let's see if it works. Hopefully it does, because I don't want to make more fixes to this. Try something again. Try something again. Ooh.
Oh, it didn't, it skipped it. So I put position 8 for O's turn, and it put X there, so it skipped his turn.
Okay. Uh, so what's happening here is it never got to the else statement because they should have came back in here. Um, so you pressed 7 the first and the second time. Is that correct?
That's correct.
So it got to line 65 and it passed, right? Because when it got to this first line, it never got to the else statement because technically this was correct, right? On line 65.
I see what you
And
mean.
and then it went in here into this if else statement. It failed this part.
And it just put in,
Yeah.
it just
So
went to the else.
right. So instead, what we can do as well, instead of doing that, let's go ahead to save time. We can probably run this within these else statements.
I see what you mean, like put it into each line, put it in each one.
Hold on. Actually, we'll put it. Mm, please choose another spot. Can you scroll up here a little bit on the terminal?
Oh,
Please choose another spot. So I did prompt you to choose another spot, which is good. But what happens after this runs?
it's just I think it's just going over to the next player. It's just going
Yeah,
keep choosing, and it just keeps switching turns.
right. So we need to put this in line 67. We need to put it in line 73.
I wonder if are these counting turns? I kind of want to keep trying. Yep, see, it that was 9 turns, I guess.
Okay, how about we do this? We're going to do some formatting. So, yeah, copy line 83 and 84 and then replace it on line 67,
Hmm, I thought they
73, or I guess 74 now. And then 81. It's going to be a little sloppy, but that's okay. It'll get it working. And then, yeah, this should work. Try it out now.
okay. All right, do 7. That put 7 there. Let's
Yes.
do 7 again. Invalid choice. It didn't do anything. It didn't update the
No, it's good.
board.
It's good.
It's,
Yeah, it's asking you for input again. Type it
I'm
in
gonna
again.
put I'm gonna put 8 now, right?
Put 7. Put 7 again, just in case.
Oh,
Okay, no, no, we're getting there. Uh, right here, the input statements, they need to be converted into integers types,
the input. Okay,
right? Because these are
simple
supposed to
enough.
be inputs. That's the reason why it failed. We're getting there. So we're asking them for input again, but because we didn't convert it into an integer, which is what we're checking for, we got an error. But that should still be there though. Put that back.
This I'm
Yeah.
worried that it's going to.
No, make sure it's integer as well, and we should be fine.
Okay.
Because this we need to ask for input again in the event it's out of range, out of
Mm,
9 and 1, right? So we still need the else statements. So
okay.
try this
7. We'll try
7
7
again,
again.
again, again. Try 8. There you go.
There we go.
This is working. Okay, cool. So we got something working now. All right, so that takes care of that. We can obviously come back and do some reformatting. That's okay. But we got a working program. That's what's important here. Now the next thing was to check uh, no winner. We had no winning combinations. So show me where we were calculating for winning combinations.
Okay, these calculate
Just show me
winners.
a couple, just like 2 or 3. Explain to me what's happening.
Um, or like go through the lines of code basically. So this first one, so I kind of separated them so they're put together. I could probably caption them, but or comment them, but this is just checking to see if everything in column wise is an X.
Hmm.
So the first column, the second column, the third column. This is doing the same thing, but it's going to go through the rows.
Right.
So as you can see, they're all the same. These ones numbers change, but it's top row, top row, top row, so on and so forth. And then this is checking diagonals. So
Okay.
you can see top row, middle row, bottom row, but it's changing, and then it's the same thing but flipped. And then I just copied this, did this down here, but I changed everything to O's so that it'll check to see if O is the winner versus X.
Sure. Okay. I won't ask any more about that. We'll get a different example. I'm not saying it's wrong, but
No, there's better
there
ways.
is definitely a much better way we can do this. But that I'll take it for now. And the last thing was draws. What happens if do we have any draw? What happens if nobody wins?
So I had an else draw statement. The problem is if it didn't find a winner, it just said we have a draw every single time. So what I need to do, I don't think I ended up getting that done, did I? I think what I needed to do was to integrate that 9 turns had been taken and then to display a draw.
Sure.
So let's
All it
see.
really is once the while loop is done, it's adding like a line at the very bottom. If there is no winners, right? If somehow uh we
It,
get that far in, we have if total turns is equal to 9, then print out it is a draw, right? It's a pretty simple fix. Uh,
yeah.
make sure it's not in the while loop. It should be outside of it, right? Because what's going to happen is if total turns is equal to 9 or greater, then it's going to stop running, and we should just have one final print statement saying, you don't even need this right here because this is going to stop regardless. At some point, if nobody wins, total turns is going to equal to 9, and there's no other code to run, so nothing else will happen. That's how we end up leaving the program to begin with. So what that means is all you really have to say right here is a print statement saying it is a draw because we never
Mm,
return anybody else as a winner,
I see what you mean.
right? Right. Now, I think that should conclude everything. Let's go ahead. Does anybody have a much more efficient way of checking winners? Nobody. Everyone did it just like Michael.
Come on, Nick. I know you got
Much,
something.
much more efficiently.
Yeah.
I wouldn't call mine much more efficiently.
Okay. How would you describe
Approximately the same, just with a couple little shortcuts added in there.
it?
So
That's
instead of,
fine.
he has his broken out into two whole hard-coded sections, one for X and one for O. I just did a for loop that iterates over a list of that just contains X and O, and it checks each one, so it cuts that code in half. Not groundbreaking or anything; it's just a whole lot less to write. And then for the rows, I just compared if they all had the same element in them, and if it's X, then X wins. If it's O, O wins. The columns and the diagonals were still hard coded, and they're kind of ugly.
Okay. I have one solution. It looks long only because it's in C sharp. So it won't, it's pretty long. And I understand if you don't understand C sharp, I don't expect you guys to. Uh, but essentially what I did was I grabbed row 0, which is essentially like your row 1. It's a little confusing for C sharp. And I just checked the row for column 1. I checked the second row for the same column and the third row for the same column. Um, and so this is checking for winning combos vertically from left to right, right? Right here, I'm grabbing all my rows. This is going to be row 1 and column 1, row 2 and column 1, row 3 and column 1. And this is within a for I in range. So column ends up increasing, but the rows are hard coded. So I'm able to check every single column on each row because of the for I in range, right? It was a loop that does it 3 times. So every time that I loop through, I check each row for the current column that I'm on. Obviously, column is going to be equal to 0 the first time it runs through. So I'll check every item at index 0 for on all 3 rows. And then once column goes to 1, it goes to the next column, so on and so forth. So this right here, there's one line of code. Check every possible combination column wise. This line of code right here, check every combination from top left to the bottom right. So I grab each row right here, row plus 1, and row plus 2. So I got row 1, 2, and 3 using the 4 iron range. And then the columns are also being increased. So I was able to check diagonally like that. And then I checked diagonally the opposite way from bottom left to top right. So that equals my X. And then I checked horizontally. So honestly, I did 4 if statements, if else statements to check every possible combination. It looks sloppy because C sharp, if you're familiar with C sharp, it's very deliberate, verbose. You have to like be very specific on how you type it out. So it can get very confusing. This is the cool thing about Python. Everything you guys just did was in much less code, and I did this in C sharp with 258 lines. That's the beauty of Python, right? Python, how many lines of code? Let's say Nick, how many lines of code do you have?
195.
Right, you did it in like 70 lines of code less than me. If I was doing it in Python, I probably could have gone there with like 150 probably. Um, and I would have cut this in half. That is the difference between a high level language like Python compared to a language like C sharp, where you have to be very specific to how you write it. Also, notice that all these are classes as well. Languages like Java or C sharp, they put everything inside of classes, and you have to specify everything. Like my integers, my strings, even my classes. When I create a variable that's going to be a class, I have to specify it's going to be of type board. The name of this variable is called board, and the class I'm about to create is a board. It's very, very, very particular. Um, so that's why I believe Python is superior, personally. But yeah, I was able to do that with 4 if else statements. I just lost it already. Right, one if statement here, one if statement here, one if statement here, and one if statement here. Using a for I in range, because you can just use that I in range, right? That temporary variable, and just add +1 +2 to be able to check multiple rows at the same time, right? So definitely leverage that. That's what concludes this class. I'm gonna go ahead and stop the recording now.